My name is Ogunleye. So I just want to try and pronounce it well. Yeah. So very quickly before I'm going to be talking about this, resource scheduling and allocation in HPC cyber infrastructure. So I worked for CSIR for about 7 years. And so while I was at CSIR, I learned some things from some senior colleagues. One of them is actually sitting here, Dr. Apisitole. You will know him. So last year, we met at this conference again, and we reconnected, and he told me about the project that the CSR is actually doing with the University of Mpumalanga, where I am happening to be working. And since then, we've been, because my research interest is in data science, machine learning, and artificial intelligence, I've been working on HPC, trying to understudy HPC, because I realize that it's actually a big thing that many people are not, or many organizations are not looking into now, and it's basically solving a lot of problems, especially when it comes to resource computing, in terms of how this infrastructure actually provide innovative solutions to the development of the society. And so basically, these are some of the things that so the university then, when we rekindled the I would say the collaboration and support from the CSR HPC, I started doing some work and research, and I started understanding what HPC is. So those are some of the things that I wanted to see, because I was actually made to lead the project because the person that was in charge before was leaving the university. So I was leaving I was then leading the project, and I started doing a lot of research around that. So in this presentation, quickly within the allocated time that is given to me, I'm going to be talking about, we're going to be exploring how HPC systems and infrastructure actually handle scheduling and allocation, the challenge that could be faced, and the emerging solution with special focus on South Africa case studies. So I'm just going to be presenting some of the things that I found out in the research that I have done. It's not a complete research, it's an ongoing research. So we know that when you look at high performance computing, it's a system that has played a pivotal role in modern scientific research. It enables complex simulations, analysis, and large-scale modeling across disciplines, such as climate science. The last presenter talked about weather, genomics, physics, and engineering. So, please do not misunderstand me when I say this. One, we then wonder, why do we have to give our data outside? DIRISA actually came to UMP early this year, if I'm correct, and we were talking about generating our own data that researchers, students, postgraduate students, researchers across various institutions and the country can use, leverage on. Why do I have PhD students that I'm supervising? I have master's students that I'm supervising. Why would my master's student want to do work, maybe a machine learning model or predictive model on cancer, and such a student will have to go to Kaggle? I'm not sure if anybody understands what I mean by Kaggle. Kaggle is a data repository that is owned by Google. To then go and get data that are not meant for us, to make prediction or to develop a model and come and say, I did this in South African context. Those are some of the challenges that we are facing in Africa, not only in South Africa. It's an African dilemma or problem. So DIRISA came with an idea with a data repository, and then I started looking. When you have this data repository, what is going to happen? Where are you going to put it? Those are some of the things that we are lacking in Africa. And I used to tell people that the next world war is going to be fought over data, not because of oil. You already see what social media platforms are already doing. So some of these things we know. So high performance systems, it provides immense computational power. And Africa, especially South Africa, which I think is actually being championed by CSR, CHPC. So the cyber infrastructure, basically, when we're talking about cyber infrastructure, it includes the software, the data repositories, and collaboratory platform that enable effective use of HPC systems. I was making a presentation last week, and people were talking about artificial intelligence. Then I displayed my final year result that I got 23 years ago when I was in final year in the university. That was 23 years ago. And in the result, there was a module called artificial intelligence. But artificial intelligence is now the buzzword about 2 or 3 years ago, especially in Africa. Why do you think that is so? It's because we've been doing the same thing that they've been doing in the West. But the problem is we have lack of access to resources in Africa. That is why internet become something that we see as a luxury in Africa. But actually in America, if your house does not have internet connectivity, is one of the criteria that people are going to use to rent a house out. Lack of connectivity. So these are some of the things that we're lacking in Africa. We do not move into some of these things quickly, and until when it has become old, then we started coming. So when you have HPC, one of the challenges is how to use the system. It's an infrastructure. It's actually not a system. It's a platform. It's not a system. It's an infrastructure on its own. So we then say effective resource scheduling and allocation in HPC. So all the systems grow in scale and sophistication. Right. And in HPC environment, resource scheduling basically is very, very important. It is very, very important to have a resource scheduling and allocation to determine how tasks are assigned. So that, to the hardware resources such as the CPU, the GPU, the memory storage, and the network bandwidth. So cyber infrastructure, which is basically the integration of advanced computing, right? We notice that it has a large-scale data storage and high-speed networks. It adds layers of complexity to resource management. So when Dr. Apesitole came, and he told me and said, we are working on this for you, and why are you not taking this resource up? Then I take it upon me, and then I realize that this is actually not something that is new. That is small. It is huge. It's a huge thing. Most of the bioinformatics, do you know that most of the researchers in Africa will have to take the result of their data or their data outside the country to analyze because they do not have appropriate system, and those who have the system, they do not have the knowledge, know-how to operate the system. As a result, they have to take it to Finland, to Germany, to the UK, to America to analyze this large data set of bioinformatics research that they are conducting. So we are saying that these are some of the things that they need to put into consideration to know. Then say, why? Because the heterogeneity of the hardware, the dynamic workload demands, and the multi-user environment, it requires resource scheduling algorithm. So as we move along, we said these are the traditional approaches that have been used before in the context of the first come, first serve, the first serve, the shortest job first, and backfiling. But they have evolved to meet these challenges, and more advanced strategies like priority scheduling, gang scheduling, HPC, and hybrid scheduling offer increased flexibility and efficiency. Take note, I am a lecturer and my job is to impart knowledge. When I do research, the purpose of this presentation is not necessarily to give you the sophisticated and the beautification of what we have done. My job is to conscientize you so that you can see how to move into this direction. Especially if there's any postgraduate student, postdoc student, PhD student, or upcoming researcher in this gathering. It is very, very important. So, also, another thing is energy aware scheduling. They also gain importance given the significant portion of operational costs that energy consumption in large HPC system basically account for. We are busy working on the budget, and we realize that this system is going to go up a lot of energy. And you know, at least let's even thank the government. We do not currently the issue of load shedding seems to be, in quote, a thing of the past. But at least you cannot operate an HPC system or infrastructure where load shedding is the order of the day. And that may have accounted for one of the reasons why in Africa we are backward in some of these things. So we said, therefore, having an effective scheduling strategy when you are using HPC systems, and I can tell you authoritatively that some institutions are already having HPC systems. UWC, UP, VITS, those are the three that I know within the country, besides UMP, that is setting up its own infrastructure through the support of CSR, CHPC. So we said, when you have these systems, having an effective scheduling strategy is very critical for maintaining fairness among users, optimizing job throughput, reducing waiting times, and enhance efficiency. So these are the cyber infrastructure, the overview of the cyber infrastructure that has compute nodes, networking, the storage, the middleware and software, and these are basically what some of these things do and how to leverage upon their capabilities. So this is basically how what some of these things do when they just an image of the compute node, the scheduler, the network infrastructure, and the storage system, and each of them. So the storage system basically are a fast SSD. So I'm going to move very quickly to talk about the key features, the scalability, reliability, and energy efficiency and importance. But because my presentation is available, so I'm just going to quickly move to some of the things that I have in terms of the case study. So the case study, if you look at what South Africa has been doing, South Africa has invested significantly in high-performance computing to support scientific research, industrial development, and socio-economic growth. But the question is, how do we leverage on this investment? That's a very good question. And two key investment I know based on my study, there may have been more than that. So please do not use me as a reference that I say two. There may be more than two. But two key that I know is the CHPC, the Center for High Performance Computing at CSR, and the Square Kilometer Array project. So if you look at the CHPC, it was established by DSI and as CSR. So it's a cornerstone of the country's cyber infrastructure, and it provides researchers with access to cutting-edge computational resource and tools. And that is what I think the Dr. Apisitole's team has done with what they have given to our institution. So these are some of the things that they have done. The primary application, climate modeling, genomic sequencing, scheduling and allocation techniques that they used, and this is the impact on the research. And please remember, note, this is based on my research. I may not have gotten the accurate. So please, like I said, the purpose of this is to conscientize you so that you can move in more into finding out more about this. So while I'm striving to be an expert in this, I'm not totally an expert. Another one is the SKA, I'm sure everybody knows the Square Kilometer Array, is a conglomeration project between, I think, South Africa, Australia, and New Zealand, basically. So it has 2 sites in South Africa, one in the Karoo, and I think another one in Gauteng. I may not know where that was. So they process exabytes of astronomical data through IDEA. So in October, we were gathered at VIT while we were doing some image data that are gathered from somebody can assist me. I just forgot that name, from the satellite images. So we were classifying those images, writing algorithms that will classify those images, and we have about 25 terabytes of images. Which computers can handle that, if not for HPC systems? So these are some of the things that they have done. These are the key features of the SKA project. And as a matter of fact, the IDEA has sponsored my school through my participation in that project to actually organize an hackathon next year. And based on that, we hope to use our HPC system. So these are some of the things that they have done. Their applications and breakthrough of the SKA array. And the impact of the research or of HPC in South Africa, they have far-reaching implications for research, education, and industrial innovation. Scientific research, industrial innovations, capacity building and training, economic and social development. So I use these two basically because the initiatives actually has generated a lot of jobs. That's what I know. Generated a lot of jobs and enhanced South Africa's reputation as a hub for innovation. So it enhances collaboration with global institutions, strengthen partnerships, and attract international funding. I propose this future direction as I move towards the end and say, if we move into this, we are going to actually become a global player and a driver in the Committee of Nations that are doing innovative research. So I said in conclusion, effective resource scheduling and allocation in an HPC environment, it involves understanding the policy, crafting well-optimized job scripts, and monitoring the resource usage. So as a user, you can maximize the system performance and minimize queue times. So advanced techniques such as this can enhance the HPC workflow. Thank you for giving me the opportunity.
Thank you very much for the presentation. And as I said, we'll get the questions at the end of this session. And this is okay. Thank you. Okay. Yes.